x equals, we'll say, x plus 2. The inverse function is the function that will undo that. So, to get f inverse of x, I have to work through how to undo f of x. So if I were to plug x plus 2 into the inverse, I would need to get back to x. So it would become x minus 2. So here's why. If I plug f of the inverse of f of x, I should get x. So an inverse function undoes each other. So let's see what happens. So if I plug x plus 2, which is my f of x, into my inverse, I get x plus 2 minus 2, which is x. These functions undo each other, and they leave me with just x. So if I had a function like f of x equals x squared, how do I find the inverse function? And that's what we're going to be looking at with trigonometric functions. How do you find that inverse function? What would undo it? Well, the inverse function would be the square root of x. Because if I take x squared and take the square root, I get x. But, and here's where this relates to trig functions, while the domain here is all real numbers, that's not true here. The domain here will be real numbers such that x is greater or equal to 0. We can't have a negative number. So there's not always an inverse at all values. So inverses may have a different domain than the original function. And that's what's going to happen with trig functions. The inverse will have certain areas where the domain is undefined. So let's go ahead and transition into that. All right. So here's the graph of y equals sine x. When we take the inverse, we switch x and y. So I'm going to write the inverse over here. So we could say x equals sine y. That would be the inverse. And of course, if we solved it for y, it would be y equals inverse sine of x. But I'm going to go ahead and use that top version to help us think through what's happening. So, compare the graphs here. Our new graph would be vertical. So it would go something like this. Here's x. Oops. Here's y. And now y would be in pi. So this will be pi. Call this 2 pi. Down here we'll have negative pi. So the graph is going to start, it's going to come out to 1. Oops. Gotta get used to writing at this angle. There we go. It's going to come down. Oh, hold on. I know what I did wrong there. Those should be... Let me move that in so I can make this actually look decent. Make that one. There we go. So we go up, we come down, and it continues. So that's one rotation. Oh, I'm doing it upside down again, though. That should be -1. That's 1. So I've been turning my tablet on my side to do the writing, and it makes it look upside down from here. There we go. So that's in the positive direction. Coming down this way. 2 pi. Get something like that. Alright, so here's the problem. This is a function. This is not. Vertical line test, you can see it cuts right through it multiple times. So, being the resourceful people that we are, instead of saying, well, this won't work, we restrict the domain. This is true for all trig functions. All of them, you can only have one segment. So look where we choose to restrict the domain. So on sine, they said, well, what if I just took a segment of it from here to here? That little segment is a function because it doesn't cross. It passes the vertical line test. If I draw a vertical line, let's draw a little vertical line. I can drag that straight across without ever passing that orange line more than once. It works nicely. All right. So that is from halfway between 0 and pi, or pi over 2. So that's negative and positive pi over 2. So we say that y equals the inverse sine of x will have a domain from negative pi over 2 to positive pi over 2. So when you find your solution, we're only looking at angles that fall in one section. So think of our unit circle. Our solutions can only fall from negative pi over 2, so from here to 0, or from 0 to pi over 2. So we're restricting what angles we're allowing to get as a result. Now, there could be infinite answers from here, right? There's an infinite number of values I could put in for x and get that y. Or an infinite number of y values I could get for any given x value. So right here, I can get this, 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 and it keeps going. But we're only interested in one, so we restrict it to only one, this value. That's what they're doing with these. They're trying to make them function so we can work with them. So now look over on page 567. They show you the restrictions of the three main trig functions: sine, cosine, and tangent. So the inverse sine, or the arcsine, is restricted from negative pi over 2 to pi over 2. Whereas cosine is restricted from 0 to pi. And tangent is restricted from negative pi over 2 to pi over 2. So tangent and sine have the same limitations, but cosine has unique limitations. And note the reason for that being, that's the section that would be, if we did it with negative pi over 2 to pi over 2, cosine would overlap in that area, because cosine would do this, and then it doesn't pass the vertical line test. So that's why. So let's look at a few examples here. So our first example, example 1, find each of the following function values. So they're just going to give you a few problems and ask you to work them. Alrighty. So here's what they've given us. They've given us 3 problems. Inverse sine of root 2 over 2, inverse cosine of negative 1/2, and the inverse tan of root 3 over 3. So when we go to our unit circle, we need to remember, though, we're not using the whole unit circle. So I'm going to put in red, my restriction goes from here to here for sine. So if I wanted to draw a box, say right through here, nothing on the other side of that, only values in this box. All right. And then the next thing I have to note is that these values down here are labeled incorrectly now. This is actually negative pi over 6. This is negative pi over 4. And this is negative pi over 3. Because we're now just going in the reverse. This angle and this angle are opposite. This angle and this angle. So you get the idea. So that's the goal. So now that I have that, where would sine be equal to root 2 over 2? And that's here. Now it's not here because this is negative. And the negative is not part of what I have. So pi over 4 is the only answer that falls into the appropriate domain. All right. So let's clean that up and get our domain for the next problem. All right, so cosine. Let's do cosine in blue. Cosine goes from 0 all the way up to pi. So now, instead of having that same box, our box is up here. Cool. So our answer has to be in this box. We don't need to relabel anything. Everything is already labeled positively and correctly. So, when is cosine equal to negative 1/2? Now we have to have that negative in here, so this one won't work. So we keep going along, and right here, cosine is negative 1/2 at 2 pi over 3. Now again, you can see cosine would also be negative 1/2 here, but we don't select it because that's not in our box. The cosine domain ends at pi for the inverse trig function. So inverse cosine never comes past pi. That's how we know that we got the right answer. And I'm going to move tangent here down. There we go. So we can do this one as well. So again, erase the box and the previous material here. And tangent goes back to the same domain we had with sine. So we're cutting a line straight down the middle and saying that we are only going from negative pi over 2 to pi over 2. This is now 0, and these are all negative. Negative pi over 6, negative pi over 4, negative pi over 3. Okay. When is the tangent negative root 3 over 3? So we come down here and we say, well, let's see. Tangent is sine over cosine. Well, what about right here? This will be negative, and we'll have negative 1/2 over root 3 over 2, which is going to be negative 1 over root 3. But if we rationalize it, negative 1 over root 3, we don't like that root in the bottom, so we multiply it like this, and we get negative root 3. Oops. Over 3. So it's going to be right there at negative pi over 6. So that's how we're working these problems using the unit circle. The challenge is, write out, like I've been doing with these boxes, show where your domain is. If you have a unit circle you can write on, that's an excellent tool to use. If you don't, just keep it in mind, don't go past where the domain ends. And notice I did not say 11 pi over 6. 11 pi over 6 would not be correct, because 11 pi over 6 is over here. That's not within the domain of the inverse tangent function. So those are how you calculate the inverse tangents with one example.